Alright, so guys, synthetic division. It is fake division. Takes all the variables out of the problem, allowing you to work just with the numbers. So, for this first problem here, we're going to use synthetic division to divide x cubed minus 14x squared plus 51x minus 54. We're going to divide that by x plus 2. So, this part right here, you have to make sure that it is written in standard form and you are not missing any terms. Are we missing any for this one? No. Now, for this part over here, in order to do synthetic division, that must be x to the first, and you really need your coefficient for that term to be a 1. If the coefficient is not a 1, we can still do synthetic division, but we've got to fix it first. If my exponent is bigger than 1, you can't do synthetic division. It doesn't matter. You can't do it. So, here's what you've got to do. And like I told y'all a minute ago, the first time you see this, it's going to be really weird. So just bear with me. So, if x plus 2 is a factor, then blank is a root or a solution. Okay, what number goes here? Negative 2. Okay, so what you're going to do when you set this problem up is you're going to start out with a little half box over here, and that possible solution goes in that half box. So I'm going to put a negative 2 here. The easy way of thinking about that is to look at your binomial and just do the opposite of that number. The opposite of that number goes in the box. Then we're going to take a look at this polynomial and do just the coefficients. So that is a 1, a negative 14, 51, and negative 54. And I spaced those out a little bit. Okay, so this is my root. These are the coefficients. And now, on your notebook paper, under the coefficients, I need you to skip a line and then draw a big, long equals bar. And for this problem, I'm going to draw lots of arrows. And it's going to get a little jumbled looking for this one, but I want you to see where everything's going. For the next problem, I won't draw any arrows. So, step 1, you're going to bring that first number straight down underneath. Then, you are going to take the number inside the box times the number underneath, and you're going to put that answer in the next empty spot. So, negative 2 times 1 is negative 2. Combine that column. So, negative 14 minus 2 is negative 16. Everybody good so far? Now you're going to take the number in the box times the new number underneath, and that answer goes in the next empty spot. So negative 2 times negative 16 is 32. Add that column together, I get 83. I think if I draw any more arrows, it's going to get really bad, so I'm going to leave this last one off, but follow the same pattern. The number in the box times the new number underneath gives me negative 168. When I add that column together, I get 166. You're right. Yeah, sorry. I'm thinking ahead and it's not working for me. There we go, negative 166. Add that column together, I get negative 220. So now, here's what I need you to do. Right before that last number, draw this big heavy bar here. That number that comes after that bar, the very last thing, that is going to be your remainder. Now, how do we write the polynomial part of our answer? Think about what we've actually done. We divided x to the third by x. What do you get? X squared. So my first term here is x squared. The next one is x to the first. So my quotient is x squared minus 16x plus 83, remainder negative 220. Okay. When we set this one up, we've got to be real careful. So what number is going to go in my box? Negative 7. When I write my coefficients, pay attention. You need a placeholder this time. I have a 1x cubed. I need a 0 for x squared minus 57x and a positive 56. Okay, so start out, bring your 1 down, and then you multiply the box times the number underneath is negative 7. Add that column together, gives me negative 7. Multiply the box times the new number underneath, gives me 49. Add that column together, negative 8. The box times the new number underneath gives me a positive 56. I end up with a remainder of 112. So now my very first term here, what is the exponent for it going to be?
X cubed.
No, because I've got an x cubed divided by x to the first. So I will get x squared minus 7x minus 8 with a remainder of 112. Alright, we're talking about long division will always work. Look what I divided by in this problem a few minutes ago. I did x squared on the outside. I could not do this problem using synthetic division because this exponent is not a 1. You have to do this problem by long division. So, that brings us to this statement. We talked about it a minute ago, but synthetic division only works when dividing by a linear factor, which just means an x to the first power. Okay? If it is not x to the first, you cannot do synthetic division. So, I'm going to put 2 problems up here. This is the first one. I'm going to let you work them on your own, and then I'll put the answers up here and see what kind of questions you've got. Okay, I think I can get this up here so you can see both of them if I make it a little bit smaller. Alright, so there you go. Okay, most of you look like you did okay on this one. Who's got questions? Okay, you've got to be real careful of your signs. There's a lot less sign changes here, but you got to make sure when you multiply things, you multiply the signs correctly. You know, in the synthetic division, you change the sign at the beginning here, and then you don't worry about it anymore. You just have to be careful with your multiplication. For the other problem, here you go. Oops, it's still frozen. There we go. There's the number 27. So guys, here's how this ties into the stuff we did in the last section. You know, if you take and factor x cubed plus 27, that is a sum of cubes. The cube root of x cubed is x. The cube root of 27 is 3. Square the x, you get this. Multiply these together, you get 3x. Square this one, you get 9. And then same, opposite, always positive for the signs. Your what? Cranium combusted. Okay. So all this stuff does tie together. So, you know, here you could have factored this and found solutions. You can do synthetic division, and then we could get solutions from there. You could do long division and then get solutions if that's what they asked. Okay, and all of these pieces are going to continue to come together when we get to the second half of Chapter 5. So now, the next problem we're going to look at is this one. Okay, and I tell you what, we're going to do this one with synthetic real quick, and then we'll be done for the day. It could also be done with long division. But the synthetic is pretty quick. But the problem is what, Derek? The coefficient has to be a 1. But I can make it be a 1. Because this coefficient is a 2, I can divide every single term in the whole problem by 2. So then I end up with x cubed plus 9/2 x squared plus 7x plus 5/2 divided by x plus 1/2. So how many of you are checked out already and decided I'm not doing fractions, I'm going to do long division? Okay. And you can do that. It will work. But I want to show you these fractions are not that bad to work with. But I need you to leave them as improper fractions. Don't make them mixed numbers. Don't make them decimals. That makes it harder to do. Okay, to do this one synthetic, what number goes in my box? And my coefficients are 1, 9/2, 7, and 5/2. So now bring your 1 straight down. Multiply. Negative 1/2 times 1 gives me negative 1/2. 9/2 minus 1/2 is 8/2, which is 4. Negative 1/2 times 4 is negative 2. That'll give me 5. Negative 1/2 times 5 is negative 5/2. I get a remainder of 0. This is an x squared and an x. So, were those fractions as bad as you thought they were going to be? No. And here's the thing. When you divide everything by that 2, that makes it so you have common denominators everywhere, which makes them easy to work with. So, let me put your homework up here. If you want to do this one by long division, you can. When I see you on Tuesday, we've got one more thing to learn. It's going to be short and quick, and then we will just do more on the review. Okay? And I'll send the review out with reminds so that you know what we started a couple days ago, and we'll finish it on Tuesday.